Hi, everyone. I'm Adrien Viaud, solutions architect. I've been working with Micron for 2 years now, and we're going to talk about AI. A lot of the presenter I've been speaking about ChatGPT and large language model and all of this. And what we have to understand is we have a very early phase of a multi-year growth that is going to really grow fast in the next few years, and all these things are going to require memory. So if we look in the history of, big transition and revolution, we had the Industrial Revolution, we had the Internet of Age, and now we are entering the age of intelligence. And it's going to change a lot of things, and it's going to transform the life as we know it. There's going to be a lot of things about curing disease, space exploration, obviously transportation with autonomous vehicles, and our job. I hope next year I will still have my job, because AI could be, replacing a lot of the jobs potentially. So here today we are going to discuss how the Micron's products can really help fulfill the potential of AI. The first main thing to talk about is data, and we've all been together trying to resolve issues with data. Where do we store it? Do we store it in DRAM? Do we store it in SSDs? Do we store it, in a NAND? So there's a lot of questions surrounding data, and it's going to be the same thing with AI. We're going to have to find out where we're going to put all that data. We're going to need fast transfer speed and all of this. And without data, there's no AI, because the data needs to learn, needs to train that data, and obviously the hardware requirements surrounding that data are going to be, higher and higher. We've developed kind of an architecture and a stack of how we see the different kind of tiering system for that data. So if we look at the top, we have the near memory. The top of the pyramid is really where the memory that is the fastest requirement, the memory actually sitting, near the GPU or on the GPU. And as we go down the stack, we go to main memory. This is where we have DDR4, DDR5, DDR6 in the future. Expansion memory, this is an upcoming technology with modules like CXL that are going to, that are already here but are going to come out, faster and faster in the next few years. We have also obviously SSDs, different types of SSDs, performance NVMe SSDs, SATA SSDs. We're talking a lot now about PCIe Gen 5 SSDs. So all of this is coming. And then network data lake, this is where we handle a lot of the data. Sometimes, huge amount of data that needs to be trained on cannot be just held on one server. So you can have multiple servers where there's a lot of thousands of videos of, scans or AV, electric cars, driving, and all that data is being trained on by the servers. So we're going to go more into details on each of those kind of levels in the stack. So the first level is the GPU. So we know that the GPU is very hungry for data, and we need a lot of fast memory to be able to get that GPU running all the time. You have to bear in mind that the GPU, from our friends from NVIDIA, AMD, and others, it's kind of a very expensive hardware, especially in the AI. Those AI GPUs are very expensive, so you don't want you don't want these GPUs to be sitting idle and not do the work. So you want fast memory to feed those GPUs. So we released recently. This is actually very leading technology with the HBM3E. It comes in forms of stacks of 12 high actually die that we put on top of each other, 36 gigabytes in capacity, 1.2 terabytes per second in terms of performance, and we've seen an improvement of 2.5x over HBM2E. So this is very fast memory. And what's very important is that technology is also running, very low power, actually. So we use our 1 beta node to be able to build those chips. And don't ask me to sell you any of those chips because they're sold out for the end of next year. So there's a very high demand on those chips because it's not only getting that high performance, but you need also those chips to run, keep the heat down and low power consumption. So that's HBM. Then we move on, we go one step down into the pyramid, and then we go into the DDR5. So I think we see a lot of demand about DDR5. Most people are now migrating to DDR5 systems. So we're doubling the memory bandwidth prior versus the older generation. 55% increase in density. So now we are seeing 128 gigabyte modules registered DIMM. We are seeing also some real improvements in latency when we do AI inference. And again, using that 1 beta node, we're able to produce those chips which are denser, faster, but in terms of power consumption are very, very good. So using those 128 gigabyte modules, we can now on a 24-slot server board install 3 terabytes of memory. So we can have very dense configurations. This is a comparison we did with prior memory technologies. Before releasing those single die package, the only way to get to 128 gigabytes, you had to stack the die on top of each other, and that's a very expensive way of doing it. It's possible, but very expensive. And it has drawbacks in terms of power consumption and latency. And as you can see on the graph here, we're able, with a single die package, one chip, we're able to really draw less power. And at the bottom, it's a memory technology which runs at 8,000 mega transfers per second. This is coming out towards the end of the year. You may have heard of it, MRDIMM or MCRDIMM. So this is a very fast technology that's coming out, and we'll share more information actually about this next week when we will officially release it. Comparison, we often get the question, why do we need to go from DDR4 to DDR5? This is kind of the examples. You get 7 times the performance, in AI workload, in image classification and computer vision. And in terms of memory bandwidth, obviously, there's an improvement. So we did, some AI and machine learning project tests where there was a real improvement by upgrading the memory bandwidth and the speed. Going down the pyramid, we move to CXL. So if you are in a situation where your 24 slots are filled up with memory, you only have 24 slots, you cannot put any more DRAM modules, there is this expansion possibility of installing CXL memory modules. So they look like this, and you're able to add 256 gigabytes, essentially of kind of RAM, onto your server. So potentially increasing the capacity to 2 terabytes. So that's a technology. It's kind of still we have a working product. There's still not a huge amount of demand, but it will definitely progress, and it's a good way of improving increasing your memory capacity in your server if you're running out. And you obviously have increase also in memory bandwidth, and it comes in an E3.S form factor 2T. And it's hot swappable and everything. So it's definitely a good technology to look at. Going further down, this is kind of a Llama 2 benchmark we did with or without CXL, and as you can see, we had a 22 performance improvement in inference, large language model inference using CXL. So we really benefited from having that extra memory bandwidth. Going down the pyramid, we go on to SSDs. So I think most of you are aware of the benefits of SSDs. Up to 30 terabytes. We have higher capacities coming soon, 60 terabytes, and next year and in a couple of years, 120 terabytes per SSD. Currently PCIe Gen 4, but we are going to release at the end of the year PCIe Gen 5 SSD. And depending on the workload you want to do, you have to kind of choose the right SSD. So the 9400 series is our high performance SSD, PCIe Gen 4 that is. And when we compared it with our closest competitor, we were able to, basically beat it and have very good benchmark results. And the PCIe Gen 5 SSD I wanted to talk about is, I can't divulge the product name yet, but it will be announced in a few months' time. And really, PCIe Gen 5 is going to be the killer use for AI application. As you can see, what we did is we used a system with an A100 GPU, Gen 4, and another system with the Gen 5, which has a H100 GPU. And you can see that the difference between these two using BAM technology is basically 2 times more performance compared to PCIe Gen 5. And that was used in a graphical neural network training. BAM, if you're not familiar with BAM technology, is when the GPU is contacting directly, bypassing all the steps into the pyramid and going straight, talking directly to the SSD, the NVMe SSD. And that's a technology that is going to come out. It's still kind of a lab phase, but it's going to come out because there's real benefits to it. And then the last step of the pyramid, this is where we have huge amounts of data, not the fastest type of memory, but this is where we have the network data lakes. This is where we see so those high-capacity SSDs, 30 terabytes currently, but soon we will have 60 terabytes SSDs. And we've done some comparisons versus competitors, but also versus hard disks. And as you can see, for example, against hard disks, we were able to ingest 100 terabytes of data faster than some of the hard disks. In terms of our competitors, we were able to provide 48% faster performance, again, kind of ingesting data. So this is those SSDs are actually, we're selling them very well in the US with some of our big data center customers because they need extra capacity for their storage arrays. Now, if we look at kind of a scenario where you are going to have different types of hardware. On the top left, you have what we would call like a training server. So you would have a model. It could be a model to kind of look for through thousands and thousands or millions of images and try to pick up maybe disease or something on scans. In that particular scenario, you would need a lot of GPUs. A lot of GPUs with a 1-to-1 ratio with SSDs. So fast GPUs, you would need the fastest SSDs. There are a lot of memory and also potentially some CXL to expand the memory. On the right, we would look at an inference server, which has a 6-to-1 ratio between the GPU and the SSD. This is where you don't need as much GPU horsepower, but you would need a lot more SSDs because you're kind of working with the data. And then finally, in the data lake, this is where you don't really need a lot of horsepower with the GPU. You really need a lot of capacity because all that data is going to be stored across potential multiple hospitals if you're training data on scans and things like that. So you would have a big training server somewhere, then maybe each hospital would have an inference server and then also a data lake, and all that data across all the hospitals would be shared to be able to be trained and then, again, doing some inference on them. So that's kind of the scenario. As you can see, Micron has products for all these types of scenarios. So we have a really broad portfolio in terms of SSDs, DRAM, that kind of fits in all those different scenarios. So essentially AI is, we love AI because it's going to be driving a lot of memory requirements, whether it's on the DRAM side, but also on the NAND side. So that's on the data center. And we're able to fit to have products in all the steps of that pyramid. But it's not only happening at the data center level, we are going to also have a lot of things happening on the edge. As you may have heard on the news, there's going to be requirements in terms of 40 tops in terms of laptop requirements. So we're going to need more and more horsepower on the edge on our laptops. And this is where you see kind of the graphs of what they're seeing, those AI PCs coming out. And the memory requirements for this, whether it's LP DDR5X, whether it's LP CAM2 or client SSDs, yeah, the requirement will be very high. So we need faster. We are going to need more DRAM, more SSDs, and all of that whilst drawing less power. So it's kind of a big challenge for us. The other situation where we're going to need more horsepower is on our mobile phones. The predictions is by 2027 we are going to hit 522 million mobile phones. So the increase in selling new mobile phones, AI smartphones, is going to be very high. And again, we are going to need more faster storage. We're going to have UFS 4.0 and also some LP DDR5X for those mobile phones. And actually, Samsung, one of our main competitors as a semiconductor, is using those products on their mobile phone because we're providing very good performance and power envelope. And the last thing is obviously our cars. We all drive cars. They're getting smarter and smarter. We have to be careful not to have any accidents, but yeah, we're going to get to level 5 automation in the next hopefully few years. And again here, the amount of DRAM and SSDs are going to, or NAND, flash chips required for those level 5 full automation cars are very high. 30 times the amount of DRAM and 100 times the number of NAND bits required. So yeah, there's a lot of work to be done and a lot of demand for memory chips in the coming years. And this is why Micron is investing heavily, over $100 billion in building new factory facilities all over the world, but especially in the USA because of the geopolitical situation. So this is kind of gives you an overview of what we offer in terms of memory chips, whether it's HBM for the GPUs, GDDR6, LPDDR, for anything memory related, we will have some products. And yes, if you have any questions, if you want to learn more about AI, we have a dedicated page on micron.com/AI. And if you have any questions, we have a booth over there. Come see us. Thank you very much.